Hi, everyone. I'm Mani Kanuja, and I'm Senior AI/ML Specialist Solution Architect at AWS. And I have with me Emily Weber today, and we'll be talking about fraud detection use case using Amazon SageMaker XGBoost algorithm.
We will indeed. And this is our first episode in our newest season of SageMaker Fridays. So if you'd like to learn more about Amazon SageMaker, this is your lucky day. And in particular, today is an intro. So we're going to be covering very introductory concepts about SageMaker. Obviously, we're looking at SageMaker Studio right now, and then Mani's going to walk us through a few notebooks around XGBoost, so with fraud detection.
So with that, let's get started.
Great. And before we walk through the notebook, will you give us an introduction to what we're looking at here? Like this looks like Jupyter Lab to me. Can you kind of walk us through what we're sitting on right now?
Yes. So right now I have SageMaker Studio open with me, and it is a Jupyter Lab kind of an environment. So when you will log in to SageMaker Studio, you will actually be presented with a launch screen, which is not shown over here. So it will be something like this, where you will have a lot of different features that you can use when it comes to, using SageMaker Studio. But when you are developing your own models, you can just create your notebooks, and that's what I was showing you over there.
And for viewers at home, if you're looking at this and thinking like, oh, this is just the same Jupyter Lab I run on my laptop, the answer is no, it's actually not. So what Mani said was we first created a studio domain. And so that's a one-time process you do in your AWS console just through SageMaker. Once you have a studio domain created, we manage the server for you. So we manage this Jupyter server. And then you as the consumer will log into that, creating what's called a user profile. You can have as many user profiles as you want to per your studio domain. So what most customers will do is they'll take a team of data scientists and they'll give that entire data scientist one studio domain, which then equates to as many user profiles as they need. Now it gets even better because every time you create a user profile, that's again the Jupyter server that AWS is managing for you. But every time you create a new notebook and create a new app and a new machine, we're actually running on a new EC2 instance. So there are actually two EC2 instances that are in flight here. You have one instance that's your Jupyter server, which you can turn on and off to get updates, which you're not paying for, fully managed by Amazon. But then there's also this, we call it a kernel gateway application. And so that's that second instance, and that's actually running your notebook. So Mani, if we click on that little circle widget up on that top left, just below the folder widget.
Okay, that's the one.
Yeah, there we go. And then zoom that out. So those are all the machines we're actually running on. Mani, can you walk us through? Like I see a lot of numbers there. Let's unpack those a little bit.
Yeah. So for this particular notebook, it's not that I'm using all of this. I was just working on something else, and so I have a lot of them open with me. So, and that's where I would like to caution, because whatever these running instances are, that's how you are being charged. So I make sure when I log out, or if I'm not using, to just shut those down, right? So that will help you in saving the cost. So when I shut down on one instance like ML, M5 for extra large, it's basically giving me a warning that if I shut this down, then all the apps running on this or the notebooks running on this will also shut down. So it's asking me, do I shut down all? And that's where you can, save on cost as well.
Yeah, that's a great point. It does mean that you can have as many machines running as you want to, and you can have them running in all different environments. So you can have an R machine, you can have a Spark machine, you can have a PyTorch machine, you can have a TensorFlow machine, you can have one that's running on P316s, you can have one that's running on, T2 medium. So you can have a lot of flexibility. So when you're looking at sort of where to build, the reason to choose SageMaker Studio, number one, is because you have more compute power, right? You actually get more machines that you can run on top of. Number two, Studio comes with what's called an EFS volume. which means you can add as much data to the server as you want to, and it just grows all by itself. So you don't have to like restart it. You don't have to worry about out of disk errors because we'll just increase that for you. Number 3 is all of the widgets. So Mani, if we can click on that little triangle widget, and then just give this a browse. Yeah, so let's click on that. And then let's look at that drop down. So within the drop down, we have Data Wrangler, we have Feature Store, we have pipelines, experiments, and trials. And if you're thinking, wow, that looks like a lot, it is. But the good news is that that's what SageMaker Fridays is all about. Like every new session that you log into is really going to pick a different piece from the SageMaker family and then just dive into it. So today, again, we're just going to get very introductory with the one notebook, and we're going to train and host it using SageMaker APIs, but you've got the whole rest of the season to look forward to. So just want to put that out there.
Yeah, thank you, Emily. That sounds very interesting. And that's what makes it exciting as well, right? So as I talked about earlier, and with that, we'll dive into the use case and the notebook, and you'll see how you can launch a training job, prepare data, and then tune your models, and finally host your model. And we'll also evaluate the model once they are deployed to a real-time endpoint. So I've already covered why we selected fraud detection as a use case. So let's talk about how we are going to prepare our data. So in this case, we are not using SageMaker processing. We are just, because our data is small, so I'm just doing some kind of data pre-processing or preparation within the notebook itself. But if you have large amount of data, it's highly recommended that you create a Python script and use SageMaker processing job, or optionally, if you have tabular data and you want to use a visual interface for preparing your data, you can also use Data Wrangler. So all these things will come up in our next sessions.
Yeah, and you can also use Spark, you can use EMR, you can use Athena, you can use Redshift, you can use Snowflake. Like there are so many different ways to do data processing. But yeah, for sure, we're going to do some local munging here.
Yes. So in just this first cell, I'm just installing pandas. And then what I'm doing over here is in the next cell is basically setting up some
Actually,
variable.
Mani, quick question for you. So when we install pandas in this notebook, how do I use that in other notebooks? Like I really don't want to just have to reinstall this. How do I just use it in a different notebook?
So what I would recommend is you can use for example, and let me take a step back, right? So you can also select different kernels, right? As Emily mentioned when we started, you click over here and you can select different kernels. In this case, we are showing you the built-in, which are data science and base Python, and has MXNet and all. Or you can also have your custom kernels. Right. So what I suggest is if you want to, have your own packages installed, you can. So one option is that you can have your own custom kernel, have all your packages pre-installed, and then you can just keep using it so that you don't have to, do this pip install over and over again.
And there are actually, for viewers at home, there are 2 ways of doing that, believe it or not. So one way of doing that is what Mani is doing right now, which is where you pip install in one notebook, get everything installed. And then when you create a new notebook, so you go up to File and then New Notebook, when you select the kernel, you can reuse the kernel from an existing session. So it'll just let you reselect an existing kernel, and that will have all the packages. So then the next time you use a kernel, exactly. So just reuse from another session. And then the next time you use that kernel, you won't have to reinstall pandas or anything because it'll already be installed in the kernel. So that's path 1. Path 2 is actually separately building an image. So this is common, like if you're, building, say like a managed machine learning platform for like a team of data scientists. And if you have like Linux system dependencies or C dependencies or non-pip installable dependencies, super common to build like a base image, a base Docker image load that into ECR, the Elastic Container Registry, and then you just attach it to your Studio domain, and it shows up as a custom image. So that's the second way to get your package in there.
Yeah, super cool.
Cool.
Okay, so with this, let's dive into our second cell, or the second piece of code, is where we are basically importing the SageMaker SDK. So like you work in Python, and if you're using pandas or any other package, you would first have to import. So we're using SageMaker features like running the training job and all, so that's what you need to do. It's very similar to other Python packages, but of course, the features are very different. But you have to import that Python package. And then once you import that, then a few other variables that you need to define are, because when you are training the data or even preparing your data, the data has to come from some storage system.
And actually, one quick edit. So for the AWS lovers out there, you don't strictly need the SageMaker Python SDK to use SageMaker, right? Like most of our consumer notebooks like this do use the Python SDK, just because it has a lot of abstraction. So it has like single lines of code to create training jobs and to deploy endpoints. But there are two other ways to, actually three other ways to invoke SageMaker APIs. You can use Boto 3. So Boto 3, again, fully supported with SageMaker. Boto 3 you'd use inside of a Lambda function. So if you're managing an AWS account, you might like import Boto 3 inside of a Lambda function to delete your SageMaker endpoints and turn off Studio. Super common. You can also use the AWS CLI actually to invoke SageMaker API. So Aurora is an autonomous vehicles customer that I worked with last year. We did a reInvent talk together. The way they train on SageMaker actually is they just have a terminal. Like they just have a terminal up and running on their local machines. They have the AWS CLI installed into their terminal. And then when they have an image that they're ready with, then they just say like SageMaker create training job, basically using the CLI. And then that invokes our APIs in the cloud. So again, you're looking at a managed notebook experience for people who want that, but it's not in any way required to use the rest of the cloud within SageMaker for hosting, for training, for tuning, for debugging, for pipelines, for the whole process. But yeah, today we'll definitely focus on the Python SDK.
Yeah. Now I was talking about data. So for preparing your data, you need to provide access to your data to SageMaker, right? And you need to store the data somewhere. So one option is you can have your data uploaded on Notebook, which is not recommended practice, because if you have like a large amount of data and you're just uploading it on a notebook and using a bigger notebook instance, then you're constantly being charged for it, right? So that's not something that we recommend.
It's also slower for sure, because if you're trying to just upload to your notebook directly, then the only way you're going to get a good experience on that is A, if you have a small data set, or B, if you have a really big machine that has bigger bandwidth. So S3 is definitely going to be friendlier in terms of uploading and landing our data sets, and also retrieving.
Yeah, and optionally, you can also use you can also have data on the Elastic File System EFS or FSX for Lustre if you're already using that. But this one is like this session is particularly focused on a high-level introduction on SageMaker because we're getting started. So we'll use S3. And with S3, another advantage is when you have so much data, S3 is very, very suitable because it can store unlimited amount of data, like petabytes of data, and you can train your model on petabytes of data using S3, if the data is on S3. Okay, and then we are also fetching the execution role. So with the execution role is whatever role you were assigned as a user when you launched the SageMaker Studio. So with this, we'll fetch that role because we also need to provide, so when the SageMaker is running the training job or a processing job, it needs access to S3 and other services like ECR because SageMaker is containerized behind the scenes. So this role is important because it provides access to SageMaker to other AWS resources. So that's why we need to get this execution role and assign it, and you'll see when we'll use it. Okay, And then we have other Python libraries that we need in this particular use case to do the analysis, because in this sample notebook, I'll be downloading the data from public S3 bucket. So, and then I'll be unzipping the zip file that we have downloaded. So that's why I have the zip file, and I have some other packages like NumPy and Pandas, because we'll be importing data and doing some analysis on top of that. And if you need to check the version, you can use the package name which you're using. In this case, I'm using the alias because we have imported pandas as PD just to check the version. And similarly, if you want to check like a SageMaker version, you will just, because we are importing SageMaker as SageMaker, so then you can just, instead of PD, you can do SageMaker and check the version. So sometimes it becomes important to check the version of SageMaker because we keep adding features to it. So it's a good idea to check the particular version to see, okay, we have the latest version.
Yeah, and that's the case for so many data science packages, right? Hugging Face, TensorFlow, PyTorch, scikit-learn, like really all of them, we need to know what version we're using.
Yeah. Okay, so in this particular case, we'll now be downloading the data from the public S3 bucket, which is the credit card fraud data, and then we are just unzipping over here.
Cool, it is credit card fraud.
Yeah.
Literally.
Yeah, and then we'll just read it into a pandas data frame, and then we'll see how many columns and stuff like that. So if you look at it, this data is really, optimized. It has some columns like V1 to V28, 28 columns, which are already normalized for us. They have a standard deviation and the normalization is actually already done on it. So, and then we have amount and the class object, and we'll do some kind of processing. But with the actual fraud detection use case, you might not have a data which is, fully normalized and stuff like that.
Yeah.
Yeah.
Do we have any advice for customers whose data isn't already perfect? What do we do in that case?
Yeah, so in this particular example, I'll be talking about class imbalance. But Emily, I remember you were talking to me last time, I think it was yesterday, right? Where you mentioned that there might be, a lot of other data attached to our fraud detection use case, which can be like the messages from the users, IP addresses, and some textual information. And you mentioned that you can also use some NLP techniques to do that. So if you can elaborate on that, and then I can come back to this class imbalance thing.
Yeah, for sure. So typically the most common scenario with data, the first most common scenario is not having it. Like step one is we never have data. So we have to ask, we have to beg, borrow, and steal. We have to push to get access to that data, step one. Once we have access to that data, step two, it's never clean, right? It's always a mess. So we have to ask people to extract it for us. We have to ask them to extract like both the positive and the negative case, right? So please give me some cases of generic credit card transactions, and also give me some cases of fraud. As Mani's going to talk about, usually we just have a tiny amount of fraud versus a lot of no fraud, and there are a couple methods for dealing with that. Some of the features are going to be what we call categorical, right? Remember, this is for our introductory data science users. So when you have categorical features, such as I don't know, the state, maybe the bank, the name of the credit card, the name of the store, etc. A couple different ways of dealing with those. Sometimes we're going to do what's called one-hot encoding, where basically we explode that feature out, and we like add extra binary columns for every time we have a different categorical indicator. For running variables like the one you see here, definitely normalization is a common approach. It depends on the model that you're using. Actually, XGBoost tends to be pretty robust to non-normalized data. So if you're using XGBoost, you don't strictly need to normalize it. But if you're using like something from scikit-learn, if you're using like k-means or random forest, actually random forest is probably okay too. But definitely k-means, any type of deep learning model, it's gonna really prefer that type of normalization. And so yeah, that's helpful. But then let's say you also have NLP data. So you have messages, you have names, you have customer comments. A way you can add that to your data is by generating embeddings from that. So it depends on what type of messages you're working with. Some people will do kind of more classic approach. It's called TF-IDF scoring, term frequency, document infrequency scores, where you look at like how frequently the words occur over how frequently they don't occur, basically, or the total number of words. So TF-IDF scoring is an option. More commonly, what people will do today is use Hugging Face. So you'll use like a Hugging Face pre-trained BERT model or a pre-trained dBERTA model, and then actually just generate embeddings. So like you'll read in the text and then like pass it through your BERT model and just get the embedding itself, and then append the embedding to this row. So if you started with, here we've got like 28 features. So you'll start with 28 features and then just append the embedding. So you might have 128 features. And that's not too bad. If you were closer to a scale of like hundreds of features, then you'd want to use like a dimensionality reduction approach just to get the sheer number of features smaller. So principal component analysis is a really common way to do that, to learn like the underlying core components in order to reduce the dimensionality on your data set. But in this case, that's already been done for us, evidently, because our data is perfect, except for the data imbalance, which Mani's going to help us take a look at.
Yeah, and Emily, to be honest, I've used so many, NLP techniques in the BERT models, but never thought of it this way, to just, enhance your features and append to the existing features and then use it. So that's a good idea. So
Cool,
I'll
right?
try that out.
Yeah.
Okay, so now coming back to the class imbalance. So if we look at, if we just group by the frauds, number of frauds and non-frauds, you can see that we only have like 492 frauds, as well as large amount of data is non-fraudulent, right? So if you look at the percentage, it's very less fraudulent data.
The net here is, when you have a data set that is imbalanced like this, and perfectly balanced means like 50-50. 50-50 is common in like computer vision, where you can literally just stack it with as many positives and as many negatives. In the real world, what we actually want to do is we want to replicate what is most likely to happen in the actual use case. So with credit card transactions that are actually occurring, we want our model to have a fair representation of that. So if in the real world, again, less than 1% of transactions are fraudulent, it's actually helpful to have your model be aware of that so that we can plan on overcoming that. And specifically, accuracy is a misleading metric for class imbalance like this, because my model can predict no fraud on 100% of cases, right? It just says no fraud, no fraud, no fraud. And in this case, it would be, it'd be 83% accurate. And so a little bit later, we're going to learn about some other objective metrics, especially precision and recall, that help us understand and attack that problem. But let's look at some ways to approach it from a data processing perspective, which are the class imbalance techniques Mani's going to show us.
Yes. So the ones that I use are very simple techniques. What you can do is basically you have like two options, because either because you already have so many non-fraudulent data points, you can undersample those, or you can do some oversampling on the number of frauds data that you have, right? So those are the two things that you can do in order to make sure that your minority data set is no longer that minor, right? So those are the two things that I have personally used. There are other techniques as well that you can look into. But I feel because this is an introductory use case and this works, like these two techniques, they're simple to use and they work most of the time. And then you can also read about, SMORT. I've also entered a link for that. So this chapter on this book is really helpful on understanding these two techniques. So with that, and talking about, again, coming back to the data preparation stuff. So in this case, what we are doing is, so this particular cell is just getting some feature columns and label column that you can use to visualize some data if you would like to, but I'm not using it in this notebook. What we are doing over here is, because with XGBoost, you need to have your target variable to be the first one. So that's what we are doing in cell number 9. Getting that column, because a class column is a target column, which was at the end. So I'm just, using pandas data frame to get it to the first one before we can actually plug in the data for training. And then we'll just split it into the train, validation, and test data set. Test data set we'll use later to evaluate our model, but for training, we'll use the training and the validation data set. So we convert it into CSV, and then we are uploading it to S3. So because this is a sample notebook and we have downloaded the data from, public S3 bucket, and then we have to upload it back. But in your case, you might already have your data on S3, so you might not need to upload the data back to S3. And if you're using like SageMaker processing job, so these code cells that we have shared with you, you can actually put it in a Python script, use SageMaker processing job. It will process the data and automatically upload it to S3 for you. So that's just a little pointer from my side that you might not need to do that from the notebook unless your data is on the notebook. Okay. So now we need our data before the training can begin on S3. So that's what we are doing. And then we'll come to training our model. So with SageMaker, because behind the scenes, it's all container based. So first, when we decide our algorithm, like in this example, we say, okay, we are going to use XGBoost. Then what we need to do is retrieve the container image of this XGBoost algorithm. But before I go with that, there are actually two options. One is you can use the built-in XGBoost provided by Amazon SageMaker, right? Or you can also choose to use the open source package for XGBoost. In this particular example, we are using the built-in XGBoost algorithm provided by AWS. So for that, you first need to retrieve the container image of the model. And we are using SageMaker API to retrieve that container image. We provide the framework, which is XGBoost, and you can also provide the version. If you provide latest, it will fetch the latest version, or you can mention the version number to be specific over here. And then we need to define our input. In this case, our data is on S3, so we are just providing the S3 path and creating our training input, which we will use for training our model. And also, when we are training our model, we also need to understand like what kind of metrics do we need to use once the model is trained, how we'll evaluate. And I remember, Emily, you mentioned like accuracy is not the good one for the fraud detection model, right? And there are other metrics as well, like precision, recall. And we'll come back to that during the evaluation section of this notebook. But before we do that, because I always get confused with this precision and recall. So do you have any something cool thing to remember, some mnemonic or something that we can
Yeah,
do?
sure thing. So essentially, like intuitively, precision is basically the number of times you predict positive and you're right over the total number of times you predict positive. So like if I am looking for friends I want to go eat mint chocolate chip ice cream with, and let's say that out of 100 people that I run my model against, let's say my model predicts positive on 10 people. So total 10 positive predictions, but only one of them actually does, like eating mint chocolate chip ice cream. My precision is 10% actually. because I'm finding one person over the 10 positive predictions that I'm making. Because precision is literally true positive over true positive plus false positive. So it's all the positive predictions that I'm making, but the number of times that I'm right. So another way to think about it is your hit rate, where you're swinging, and you're swinging, and every time you swing, that's a positive prediction, basically. But when you hit, that's a true positive. So that's your precision. Recall is the total number of times you're predicting positive over all of the positive cases in your data set. So now let's say I'm trying to find friends who want to eat mint chocolate chip ice cream with me. And let's say that 10 of them are out there in the data set. So like there are 10 people out there who want to eat mint chocolate chip ice cream, and I detect 5 of them. So I get 5 of them, but there are actually 10 of them. That means my recall is 50%. So I'm able to capture all of them with recall. And so those are 2 different ways of thinking about it. So in fraud, it's really common, excuse me, it's really common to say that recall is more important in fraud because it means you're capturing more fraudulent cases. You're just able to catch more fraud. So those are some common ways to think about it.
Yeah, and it will become critical also, right? Because if there is a fraud and we are unable to detect the fraud, I think that will have a more cost attached to it. Instead of, even if there was no fraud and we detected the fraud, I know there will be some inconvenience attached to it. But if we look at the risk, I think that will be a higher risk that there was a fraud and your algorithm was not able to detect it, right?
Exactly.
Okay, so good concepts. And now let's move on to the training job. And we'll use these concepts when we are evaluating our trained model. Okay, so when we are launching a training job in SageMaker, what we are really doing is we are not using the compute in the notebook. We want to launch this training job in a machine on the cloud, right? And we should need the flexibility to specify any machine that we want to use based on the algorithm that we are using, right? So for example, if we are using a deep learning model, then we might want to use GPUs instead of CPU. So we need that flexibility because we want to optimize on the cost as well. Because, for example, if I just use GPU for my notebook, and now when I'm talking to Emily and discussing and doing pair programming, or maybe just coding my stuff, I don't want to pay for that time because I'm not really using the machine for what it was meant to be. And most of the time it will be idle, but I'll be paying for it, right? So that becomes very important that when you are training your model and the model needs a particular type of machine, you provide that machine. And when the training is done, it should automatically terminate all the resources.
Yeah, and another way to think about this is when you are working with larger data sets and larger models. So if instead of being able to fit on just one machine, say you need 2 machines or 3, and like again, fraud data sets can be massive. So if you wanted to train a model on literally your entire fraudulent data set, that's probably multiple terabytes, most likely. So if you're training on multiple terabytes, I hate to tell you, but that's not going to fit on one server. That's not going to fit on one EC2 instance. So we have another SageMaker Friday session coming up where you can just totally dive on training. But essentially, yeah, we have optimizations for working at larger scales. So
okay, sounds good. So coming back to our XGBoost model, right? So this is very important. So we understood the concept why we need to do the training on a separate instance, because based on our job and the model that we are, and the amount of data set and the size of the model, we need to specify the appropriate instance type. So it's literally at Amazon, we always say that we provide right tool for the right job. And in this case, we're providing you the flexibility of using the right instance for your training job. And also, in order to do that, so you need to enter some configuration. So estimator is basically our base class because we've already fetched the XGBoost container image. in our previous cell over here, we retrieve the image, right? So we already have this ECR image, a URL in this container variable. So we'll provide that to our estimator base class. We provide the role that we declared. We've already talked about that. And then the instance count, the instance type. And once the model is trained, we also need to provide the output location where my model artifacts will be stored. And then the SageMaker session, which is needed because we're using SageMaker. And if you provide instance count equal to 1, then it will launch one instance of type ML M4 extra large in this case. And we'll also install basically this container, which already has the XGBoost model on it. It will launch that container.
And again, for viewers at home, just to underline this, that is not going to show up under EC2. Remember, like these are managed machines. They're managed by SageMaker. They show up in the SageMaker console. They show up as a training job. All of the metadata on these are stored. They're searchable. You can version your data sets in S3. You can replicate your experiments. Again, all of the logical content that you need to reproduce this job is stored and saved by default and searchable by default within SageMaker. But again, it's not going to show up under EC2. It's going to show up under SageMaker.
Yes, good point. And if you provide your instance count greater than 1, then it will automatically launch the cluster. So it's fully managed because then you don't need to create a cluster. You don't need to do that. It will automatically do it for you. And then you set some hyperparameters that you need for your model, and using your, again, the estimated object that we created. And then with that, you will just do estimator.fit and then provide your input data. In this case, we are providing the training and the validation data set and S3 location of your training and validation data set. So once you do xgb.fit, it's exactly going to do that. It will launch the machine, it will launch the container on it, it will start the training job, it will look at these hyperparameters for the model, and once the training job is done, then it will store the trained model or the model artifacts to this output path that you have mentioned in your estimator. And once it is done, it will then tear down all the resources that it has generated, like the instances that you have specified. So it will tear down. So with that, you only pay for the amount of time that your training job was running. Okay, go ahead, Emily. You had something.
Yeah,
to
and
share.
we can scroll down to look at the logs. So
Yes.
when you execute this job, yep, all the logs show up here. And then when we have that output set to scrolling, then we can scroll through and view all these. All of the logs write to CloudWatch. So again, they're stored in CloudWatch. If you're bringing your own script via script mode, everything you write in the container also shows up in CloudWatch. And then again, you can view them in the console. And we're running a little bit short on time here, so I think we probably want to move on to the next section.
Yes. And then once the model is trained, then you can just use your estimator to do .deploy and then provide the initial instance count and instance type. The word initial is important over here because what does that really mean is if we have initial instance count of 1, so you are deploying your model to one machine, right? And later on, if you want to increase the instance count, let's say based on the load that you have, you can update your instance. Also, you can have an auto-scaling policy. So based on that, it can it makes it very elastic to use and flexible because based on your load, which will be the number of invocations that you have specified, it can scale your scale up and down. So what does that mean is it can deploy to multiple machines, and when the load is back to normal, it can just go back to your minimum instance count that you have provided. With that, so once your model is deployed, but you can test it within SageMaker, and you can evaluate it on the SageMaker notebook, similar to what we are doing over here, by directly calling that endpoint. So with this, let me just go over here where I've written this small function, which basically, because it's a real-time endpoint, it's not that we can just give large amount of data to it to predict, because it's not meant for that. It's really meant for you provide a small payload and then you get the results immediately, right? Especially in the fraud detection, we might need like single digit millisecond latency. So in order to do that, you have to make sure like what your payload size is. But in this case, because I had my test data, I've already split it. The test data. So what I'm doing is I'm actually splitting it into mini batch sizes of 500 rows and then doing the prediction and looking at this. And in this particular confusion matrix, as you can see, this one was easier because our data was clean enough.
Actually, Mani, let's help the customers unpack this, because we might have some people who have never seen this before.
Yeah.
So do you mind kind of walking us through what is this thing? What does it mean? And how do we use it to figure out if we like our model or not?
Yes. So this is what I'm doing over here is creating a confusion matrix. What it does is, because we have binary classification, so we have 0 and 1 as our classes, right? So these are actual, which is on the row side, 0, 1 class.
And so zero actually means no fraud.
Yes.
0 means no fraud, and then 1 means fraud. And
Yeah.
specifically, actual means the ground truth. So that's what came in from our historical data set. And then prediction means it's coming out of the model. And then both of those fall into that positive and negative classes, or zeros and ones.
Yes, that's correct. And then when we are saying that this 28,426, what we are saying is that it was non-fraudulent data. So these were the number of non-frauds, and the model has predicted it right. The actual class was 0, which was non-fraud, and the prediction was also 0. So that means it has predicted it correctly. And coming to the fraudulent, if we look at it, that our actual class was 1, and because it predicted 0, that means that it predicted that it's not fraudulent. So these 11 predictions were basically wrong, right? And that's that's what it means. Like that means that the model has classified as false negatives, right? And we have to be careful in this case because cost of not detecting a fraud when there is a fraud is much higher. So we have to be very careful when we are, kind of fine-tuning our model. And then what 43 means is that out of the 54 fraudulent number of frauds, or the fraudulent data that we had, it predicted correctly. It was fraudulent and it predicted fraudulent. So one is what it predicted, and then this was the actual ground truth. So we were able to predict. So that's how you can make sure how your algorithm is performing, right? And over here, those are the concepts that we talked about earlier, the precision and recall that comes in really handy.
And then so specifically to kind of calculate precision and recall from a confusion matrix, basically, so for precision, you look at your true positive number, which is where prediction is 1 and actual is 1. So for here, we got a 43 of a true positive, and that is the denominator. So you put 43 on the, actually, no, that's the denominator. That's the top. That's the top. That's 43. Then the bottom, the denominator, is going to be true positive. So 43 plus a false positive. And a false positive is where you predict 1 and you're wrong. So we have one case of that. So our model is pretty precise, actually, because it's 43 over 44. So we have a pretty precise model, which is nice. But our problem is that our recall is not great. And so remember, recall is the same numerator, which is 43, so the same true positive number, over true positive plus false negative, so plus 11. because it's the total number of positive cases in our sample. And so we got 43 over the total number, which would be 54. So that's what our recall would be. And so essentially what we would do is tune this model for recall, where we would try to, like literally in our automatic model tuning, we would try and point it directly to recall. Whether we do that, actually, I think Linear Learner at least provides that as like a built-in API. With XGBoost, you could potentially like bring your own script and then emit recall as your tuning metric. But basically, like we want that model to catch as much fraud as possible, because as a customer, like your head of fraud is going to prefer to review more cases, like manual review more cases, and like have to, you know, find out after manual review, like, oh, this was fine. Like they would prefer that rather than just not catching those 11 cases of fraud. Like not catching the fraud is their worst possible case scenario typically. So that's why we would prefer to tune for recall rather than precision here. Or you could use a metric that combines the two. So AUC, F1, those are other objective metrics that data scientists will use, which are more robust to this class imbalance, and then give you sort of a more holistic view of the overall solution. Yeah, that's why we're going to tune on AUC here.
Yes. So you can use automatic model tuning from SageMaker. So you basically, from the SageMaker tuner, we have that, SDK from where you can import these parameters, and you provide the range of the hyperparameters. So in the earlier example, we were just, providing some hyperparameters which were hard-coded. In this case, we provide the hyperparameter ranges. If it's a continuous parameter, you can provide like from 0 to 1, it's a continuous parameter, and so on and so forth, right? If it's an integer parameter, you provide the range. If it's in categorical, which is not shown over here, but you can also provide those, right? And then objective metric, like what do you want the tuner job to optimize the model on? So
yeah, and for any viewers at home who are looking at this and feeling queasy, like maybe, oh, I don't know what's going on here, don't worry. All of this is extremely well documented, so you can dust off the SageMaker documentation, open up model tuning. We will give you recommendations. Like generally, we see certain hyperparameters affecting certain performance. We suggest tuning in specific ranges on average. So again, you're not alone. Like we have examples, we have content, we have teams and resources. Mani, I think we probably have just a couple more minutes here, but we've been going for a little bit. So let's try and wrap up as best we can.
Yes. And then you create the hyperparameter tuner job. You provide your estimator that we declared above when you're training the model, objective metric, hyperparameter ranges, and also provide the maximum number of jobs, because what we are doing with this hyperparameter optimization or the automatic model tuning, we are basically trying different hyperparameters, right? So you need to provide the maximum number of jobs that are needed. And then also so in this example, I've just 9, right? But you can, practically, you would tend to have more number of jobs. So in order to expedite that process, you can have maximum number of parallel jobs as well, so that they can run in parallel.
And so specifically what we're doing is it's called Bayesian optimization,
Yes.
Where your Bayesian optimizer will run a certain number of parallel jobs, which here, as Mani said, we have parallel set to 3. So you're going to run 3 parallel jobs. All of those have different hyperparameters based on that configuration that we provided up top. We run those 3 parallel jobs based on those different configs, and then take a step. And in that step, we're actually taking the output and we're fitting a model. We're fitting a Bayesian optimization model, which will then suggest the next hyperparameters. And so then that next set of jobs, which is going to be another batch of 3. So we had jobs 1, 2, 3. Then we have jobs 4, 5, 6. Those all execute with, again, different hyperparameters as specified by the Bayesian optimization. And then we'll complete until we've hit 9 jobs, or until the early stopping kicks in, and we've hit the plateau in terms of the validation AUC increase that we're going to be able to achieve.
Yeah. and basically using Bayesian optimization for reducing the hyperparameter space, right? So then we just do tuner.fit and it will run those training jobs. And once it finishes running all the training jobs, you can basically find the best training job and then just deploy it with the tuner API. And the similar fashion, you can basically evaluate the model that we did it in the beginning. So that's how you will do automatic model tuning and optimize your models. And if you have any questions, feel free to email us or just connect with us on LinkedIn. So we'll be happy to help you. So please reach out to us as needed. And this marks the end of our session today. And Emily, do you want to summarize it?
Happy coding. Like go forth and develop on SageMaker. And I'd say, like, remember to think big. Like, this is the time for data science and machine learning to solve big problems. Like, be ambitious. Like, go after big data sets, go after big models, go after big problems, and just ping us. Like, we exist to help you do interesting and cool things. So, like, please think big in the scope of what you want to accomplish with data science and machine learning. And odds are there's enough skill set out there to really help you get that done. So don't be afraid.
Thank you, everyone, for your time today.
Cool. Awesome. Thank you, folks. Bye.
Thanks. Bye.